So this is my first attempt at explaining this topic. So I'll give it a try. If at any point in time, if I become very geeky, put your hand up and stop me. So it's like I'm switching hats as I go along. The whole thought process was thinking about thinking as a human and then as a machine. And how do I transition from being a human to being a machine and being an emulation? And we as humans, how do we really value our thoughts? Would we consider ourselves as authentic? Because as you recognized before, Fabian was kind of describing, how the way we describe ourselves being different from machines is the originality. And I'm just questioning the question of originality. So I'm going to give it a try. And stop me whenever I go geeky and if there are things that isn't very clear. So there you go. So everybody has one of these. I'm assuming there's nobody in the audience who doesn't have one of these. And there's been a lot of work that has gone into it. We've always been learning new things about this 1.5 kilo worth of stuff up in a skull. I mean, a brainy cage, right? It's a cranial cage that you actually have, and the most valuable thing you can have. It takes up around 8% or 8 to 20% of your total energy that you consume. Oh, yes. Okay, that's good. So, why is it not going? Right. So, over time, our understanding has been changing. As more and more ability to understand the internals of a brain comes in, we have a better understanding of which parts of the brain gets lighted up when we see things. The functional MRI have been very, very, very helpful in allowing us to understand, how various parts of the brain really work. Now, you would ask me, why is it important, right? So, in general, what happens in our brain is a whole bunch of processing. And there's a bunch of metacognition that's actually happening. And we really don't have like very, very, very highly sophisticated models that we can actually take off the shelf and use it and pretty much say, this is equivalent to a human brain yet. So it might happen. So if you were to actually measure the ability of cognition and put a scale against it, I think some of us, at least in a social and empathetic scale and things like that, we might miss a few steps. So this is not a linear one in the sense like you have to go through the whole path to get to wherever you need to be. But it is possible that we can assume a human to be at scale 10 and the so-called superconsciousness to be something that evolves at some point of time. Different people have actually proposed different possibilities. One possibility is the fact that it could be alien, as in something could land on Earth and there emerges something. But in all likelihood, the likelihood would be we do something, we as humans do something, and that will result in something that has that consciousness in that sense. Okay, now, given that that's a possibility, we could probably think about we humans and machines evolving along. The reason I thought I should mention this is like, somewhere through this process, there's an interaction that's actually happening. And if you think about your iPhone, that's a good example I normally have. It actually changed the way you actually think. So it's like, normally if you want to go somewhere, before the iPhone, you would have actually looked at the map and go, oh, I need to go there. I need to understand how to get there. Now, it's an extension of your brain. You have an iPhone, you take it, or an Android phone, you take it, and the moment you get stuck, Google Maps, or whatever maps that's in there. It's an extension of your brain, right? And actually it's happening. What you have described there is a brain-computer interface, right? It's a primitive one. We're using our eyes and our fingers to actually do the interface. So you have a real bandwidth restriction. The number of bytes you could send and receive is pretty low, right? And this is an enhancement that actually we brought to our brains without even hacking our interface at all, okay? And this is only going to improve. As things improve, as Moore's law happens, as you can imagine, like 10 years ago, in 2007, the first time iPhone came out, the functionality that it had and the functionality it has now is very different, right? And the same interface is still there. We as humans still have the same old interface. Our interface is not changing. And this is a key thing that we all need to understand. And this will be the bottleneck for human evolution as such. Okay? So if humans have to improve, we need to find a way to drill a hole through the brainy cage I was showing and look at that very interesting 1.5 kilos of stuff that's stuck inside and find a way to send signals in and take signals out. Okay? So before I go into that, I probably should say this, right? If you were to think about that improvement in human evolution, the first thing that will happen is like we plug something in without actually opening up our skull cage, like an iPhone. And then at some point of time, we would actually open up our skull cage. I mean, it's already happening. So there are retinal implants, right? So in theory, a retinal implant is allowing you an interface from an electronic signal into impulses into your optic nerve. And the optic nerve is a high bandwidth bus that goes to the base of the cortex, right? Oh, I should probably show a picture. Okay, let me see. Sorry. I should have a picture so that I can actually... Oh, yeah, hold on. Right, guys. Where's my pointer? Which one? Take the other one. Okay. Press the thing. Oh, yes, yes. So, over there, over here, that's where your optic nerve actually... So, this is the cortex, right? And from your eyes, there's just two things that goes in, and it crisscrosses across and goes into the optical cortex, and it actually supplies the back part of the brain, right? So this is like a high bandwidth channel, a bus, if you were from a computer science perspective or a hardware perspective. You have a bus available to you. And if you have a retinal implant, pretty much you already hacked your brain. You got a chance to put data into your brain. We haven't got a path to get it out yet, but there are ways of doing it. But you know, I'm just describing what is actually happening. So now the next logical step to happen, if you hack your brain and put stuff in, is to actually understand, you know, scan the brain properly, right? Understand what it does, understand its connections, and then do an emulation. And this is a very interesting book from Robin Hanson. If you have a chance, you should actually read it. It kind of looks at it not from a technological perspective, it actually looks at it from a societal perspective, an anthropological perspective. And that is why it's a lot more relevant and a lot more interesting. And for everybody who's interested in where humans are going, this is going to be one of the key steps before the so-called real singularity might happen. At least in my opinion, it's like this seems to be like a possibility more easier and attainable in that sense in terms of computational complexity than other solutions that are out there. Okay, let me try my next one. Okay, so there's an important thing that I thought I should mention this to you. Everybody thinks we as humans are unique because we have memories. And we have ability to create, dream is a memory. If I were to think backwards, yeah, of course, when you wake up, you have memory of something that you saw while you were asleep. That's why dream is a memory. And as you could recognize, most of our memories are really fragile. It's very biased. And if you have any memory of anything happening, you should always cross-validate them with some data points that's available. Actually, this was a very recent study that was published in Science, I think. And they had like a whole bunch of things that showed that whenever people have memories, it doesn't really relate to anything real. And this actually should make us question the real basis of human society. So if you were to be taken to court, the thing that happens is you be cross-examined, right? What is happening here? Somebody's asking you questions about your memory. And somebody else's life is actually hanging on your recollection of something which is totally screwed up. Okay, and now, this is why I found this very interesting. So humans seem to value authenticity of their thought and authenticity of their memory way above everything else, even when it's proven to them that it is not really true. Okay, so now this is a question of privacy. Given that I am giving this talk in Germany, it's very interesting. Privacy, all through Europe, there is GDPR coming up. My background is in privacy and security, so I pretty much see Germany as one of the countries where there's quite a bit of, protection for privacy of an individual in that sense. And think about this, right? now the information that we are trying to protect is generally IP and things of that sort. Imagine the privacy of your thoughts. There's no debate that has actually happened in any of the so-called EU Parliament or any other places to actually think about this. So this is the thing that's going to happen when we actually have our brains opened up. The skull cages that's protecting us from the external world, when we drill a hole and connect the wires into it, if the communication goes backwards and forwards, we have a challenge there. Anybody who has access to the wire will know what you're thinking. I mean, at least that's a possibility, right? Now what happens? And what happens is interesting. What happens is interesting in a sense like both the cases that I was describing, A, when we actually just have, brain enhancement, and B, when the case we actually have an emulation as such. Both the cases, privacy is almost always lost, unless we find really unique ways of doing this. There are mathematical ways by which you can prove that you can do an operation and not allow anybody else to recognize it, but those are all theoretical, okay? We haven't actually come up with ways by which we can actually do this in real yet. So, yeah, homomorphic operations, yes, you can do that, but it doesn't really mean anything. Okay, right. Okay, this bit is, I should ignore it, but I had the slide. The last bit is the bit that is interesting for everybody. So this is the bit that's most interesting, and there's a reason why this is most interesting. I think I should probably show you the slide rather than. Okay, so throughout history, this is how things have happened. So when humans started transacting, when they do barter, I don't know if there are economists in this room, and if I say something rubbish, please correct me. I assumed barter was one of the first set of transactions that happened. So that's a direct synchronous transaction. You actually negotiate and you get your stuff done. And then professions came in. Lawyers who make a lot of money. Sorry. Any lawyers in the audience? Apologies. So they did the arbitration. And then there were centralized arbitration mechanisms. And of course, you can actually have decentralized arbitration mechanisms. And this is the bit that's of a lot of interest to every one of us. If we were to have EMs flying around, right? One of the things that you actually want to happen is that the EMs are protected. Protected from themselves, protected against other EMs, and protected other agents that are interested in the information or things that the EMs have. If EM has, in any way, shape, or form, any economic value, it will become an object of interest of people. I would say a set of all agents. Could be malicious or not, we don't know. So we need to have mechanisms by which we could allow governance to happen. So this actually possibly offers a solution. Right, let me show you. Okay, and I'm pretty sure everybody knows this. Right? Is there anybody in this room who doesn't recognize it? Okay, guys, it's called blockchain. There are lots. The next speaker actually would talk a lot about it. I'm not going to talk anything about it. So the reason why blockchain is interesting is the following, right? So it allows you to have a publicly available auditable data set. So you could actually have the whole set of rules that you apply on your smart contracts available to public, and the public could look at it and say, look, this is the rule, this is how it should be applied, and everybody should be applying it fairly, okay? I'm not going into permission blockchain, anything like that. I'm describing the public blockchain, right? And actually using that as the basis of smart contracts. So this is one way of looking at organizations and how humans and machines interact, right? So you can look at automation at the edges, and you can look at things at the center. You can actually have humans at the center or automation at the center, right? So if you actually have what I would describe as automation at the center and humans at the edges, you actually have what you describe as a distributed autonomous organizations, right? And this is really interesting. This is really interesting in the sense like, I know this has some slight connotations because of some events that happened, and I will talk about it in like 2 slides time. But if you assume it's very secure, let's make an assumption, right? Let's assume people do things properly. We do verifications and things go according to plan. This should allow us, I know that there are people in the audience who are laughing at it. Yeah, I fully appreciate it. I'm actually going to talk a bit about it and why I said those things. because all the terms actually have their own meaning, and it should be understood in the right context. It's not the first time in the world that verifiable systems were built by humans, and verifiable systems do work. And there's a whole bunch of mathematics that actually looks at that. So I wonder why. So anyways, the concept of distributed autonomous organizations, the fact is that if we were to have a whole bunch of EMs, this would allow us to actually construct governance frameworks to allow those EMs to collaborate among themselves or with us, as in the humans on the edge. Okay? So that's the reason I thought I should describe this. But other than that, that's good enough. If I go... Right. This is why some of the people in the audience were laughing. Okay? So there was an attempt made to actually do this. So first attempt was made. A bunch of researchers said, guys, stop doing this. Don't publish. Well, nothing happened. And this happened. And, well, it's a case of actually building a system and having things not fully verified. So I have a bunch of slides kind of trying to describe how this could be done slightly differently, assuming we are not going to use the parameters and the framework that the guys who did it previously did. Okay, this is no reflection on what they did and how they did. It's just the way that people from the academic world who have actually been trying to implement things in trusted systems have been doing it. Does anybody here recognize what this is? This is pretty bad, guys. It's actually written there. I can't believe you can't read it. It's a TPM, a Trusted Platform Module. Okay, so I'm assuming there are no hardware geeks in this room. Man, so bad. Right, okay. So this is the definition of trust, right? And the key thing is the feeling of certainty. I don't know what this means now. But this is how it's been defined, and the definition of trustworthy systems. Okay? Okay, so this is the key bit. A system's behavior can be validated in some convincing way. Okay? And this seems to be very tricky for everybody. And from what I understand, there have been systems previously that were around that have actually been gone through the process. Right, okay, so there's been quite a bit of work that was done on this magical hardware called Trusted Platform Module. So what it does is kind of, I would say irrelevant, but I'll give you a flavor of what it does and why it's important. So generally speaking, when you have trust, you need to trust somewhere or something to start with. There are ways by which you can actually have a totally bootstrapped trust that's decentralized. But the problem is, once such a system is bootstrapped, if you want to go back and fix something, it's almost impossible. And that is exactly what the previous problem showed us. So the DAO problem was you actually had like a kind of not really decentralized, but closer to decentralized, and you needed to fix something. There's no way by which you can go into the system and fix it. So you have to fork it to actually fix the problem. So this is a slightly lower, how would I say, slightly better situation or slightly less flexible situation. So this is a piece of hardware that pretty much used to come with all the motherboards if you ask them to have it. And then you will have a bunch of keys in there. So the way I would describe it is if you were to buy doors in a house, and doors in the house comes with a padlock, and if you want, you can activate it and use a key to open it and lock it. That's the easiest way to describe it. So you have a level of security to your house, assuming your other doors are okay and your windows are not the ones that people will be able to get into the house. So, right, okay, I am not going to describe the whole thing. Okay, the most interesting bit about the TPM is this ability to do what you call direct anonymous attestation. I shall try to describe it a bit more using this. Right, okay. So who has heard of this before? Come on, guys. Put your hand up. I know you guys have. Right, okay. So this is a way by which somebody proves to you about something. Before and after the person proving to you that they have proved to you that they have the ability to do something, you don't know how they did it. Okay? Let me explain what that means. So you have this Alice and Eve kind of thing where, Alice sat outside. Eve says to Alice, you know, we have this particular cave or this room. We know for sure that there's no way by which I can go from side A to side B. We can go in and check. But what I will do is I will go into side A and I'll emerge on the side B. Effectively, what that proves to Alice is the fact that Eve has a mechanism by which it could do that, but doesn't show Alice how to do it. So at the end of the day, Alice just knows one bit, essentially that Eve has the ability to do this. This is very interesting in a sense, like in a lot of very important questions are asked, you want to have an answer being given, but you don't want the person who is actually asking the question and getting the answer know any more information than what you just told them. Okay, I'll give you an example. Imagine you are asked to prove whether you have a particular disease or not, right? And publicly revealing that is not a good situation, right? If you were to run a zero knowledge protocol, you can actually prove to somebody who knows whether you have it or not, what it is, whether you have it or not. At the end of the protocol, the person who asked the question would know for certain that whatever your state is would be known to them, but everybody else who's actually watching this would know nothing. And this is interesting. Imagine that you have a bunch of VMs. They want to transfer information between themselves, as in validate information between themselves. They can do this because they have no way to know whether other EMs are malicious or not. And similarly, if you have your brain and you have an entity that's sat outside, you have the ability to prove to your brain that the entity that sat outside is a real one or not. Am I making sense? Did I lose you guys? Okay, I'll try once more. Okay. So imagine I have something sat outside my brain, right? So my iPhone has this interface that actually talks to my brain directly, right? And I want to make sure that my iPhone is my iPhone and my brain is my brain. And I don't want anybody else to recognize what the hell I'm talking to my iPhone about, okay? So I'm doing this in public, and I'm just doing this protocol where I run this question, right, like this. At the end of the protocol, I know my phone is my phone. And the phone knows my brain is my brain. Okay? Okay, so let me explain. Let me ask you a question, given you asked a question. So now, okay, now, you know how symmetric key encryption works, right? So imagine I have a box, and a box has a lock. And the lock has keys, right? Unless you have the keys in your hand, there's no point in giving you a box. Right? Yeah, that's the problem. So here, the thing is like you are allowing everybody to actually see what you're transacting. But what you're trying to do is literally the people that really know what they're interested in, they get the information. As in, they get validation. They don't want to open anything. They just get the validation. If it's a symmetric key operation, it's like you actually need to do a key management and a key setup. And then everybody has to be enrolled on the system. And once everybody's enrolled on the system, and in a symmetric key scenario, anybody who actually has the keys to it, whatever you're saying, they could know, right? They could open the box. Everybody has the same key, so the box opens, and everything that's inside it is known to them, right? Sorry. Yeah, so this is one of the things. And one of the other things that I found very interesting was the construct of ethics. I know, oh, this one went down. Do you know what time is it? This went down. Okay, sorry guys. So then this is the question of ethics. We were talking about difference between humans and machines, and oh yes, I have 15 minutes, yes. Right, this is a bit of work that I've been doing on the side. This is my spare time activity. And I've been thinking about, okay, so I shall admit I've been thinking about this very hard, and I've been thinking about, what could I do in my limited ability to move this a bit forward. So I convinced a couple of my friends to join me in my crazy search for stuff. So these are like a high-level scenarios that we use to look at what humans normally do and how humans make decisions, and how could you actually translate that into either machine to machine or between agents. Okay, let me try describing that slightly better. So imagine that there's an interaction between two humans, right? And we know what is ethical and what is non-ethical, right? So what we could know is like if somebody does something that's non-ethical, both the parties involved know this is non-ethical. But imagine it's the case of EMs, right? So how do they know this is ethical or non-ethical? Can you actually have a third entity in the ecosystem which actually tells them whether this is ethical or non-ethical? Or can you actually have cohorts of the system that could actually tell them whether it's ethical or non-ethical? And that, to me, seems interesting. Because it's like, if you actually have a copy of your brain given, what is the assurance that you have that that entity is actually going to be used in an ethical manner? That, to me, sounded like an interesting start of a question. Interesting start of a question. We don't know about what the next level is, but this is like the basic level that I thought would be interesting. If you actually had your brain's, how could I say, processes exposed, you want a level of assurance about privacy, then there's a level of assurance about authenticity, and a level of assurance about the ethical use of it. So, at least some semblance of fairness occurs at the end of it. So this was an attempt at doing it, but let me see. Okay, I'm going to skip that one. So this is like a classic one that, can anybody see the key challenges on this? It's a very simple thing. You guys drive. I don't drive, okay? So for me, it might be more difficult. You guys drive, so you should be able to find it easily. So the way we tried to do this was, look at all the key challenges and see what the action should be and how could you actually make a machine understand what to do. So this is what it is, okay? Case is object ahead in the lane, moves out of lane. Okay, this is classic case, and I'm sure you recognize it. Then there's a question of erratic driver. You might have alternate solutions to this problem, but these are the obvious ones we found. So you could actually use this as a basis to build other systems. This is like a very dumbed down version to actually understand how humans generally look at things and translate that into ethics, and how that could be understood by machines, and how you could actually make that, how could I say, in a compilable state and make two machines agree on something. All right. Okay, this is the stuff. If you guys get really interested and you want to hack it, go hack it. And if you have questions, drop me a note. Right. I'm going to skip that. And what I would say is, like, given I've been saying so much about all these things, I think it is possible that there might be, near EMs that exist. When I say near EMs, I mean is that, for smaller organisms, we have the ability to actually scan them to a degree. I think open worm was an example that you actually can actually look at a worm and like look at nematodes. It's like a lower organism with a lower number of neurons and lower number of connections. You could copy them, and then you could actually run it and then look at what the outcome is. So, if you could do that at some point in time, maybe. So the distribution is varied, and that's all, folks. Now it's your time to shoot me. Yeah, go for it. You want this? Yeah.
So, in one of the last slides, you had this trolley problem, I think, kind of outlined with a self-driving car. So my question to you is, would you buy a self-driving car? Okay. So would you buy a self-driving car that in certain situation would value another life over yours? So would save another life?
Okay. So let me try something. So the question that I was asked was something along the lines of, do I really value my life? Summary answer. Even though I consider myself to be an effective altruist, to a large degree I'm selfish. I'm unlikely to do that.
But that kind of solves the trolley problem, because in the end, self-driving cars would only be successful if people if people buy them, and people would only buy them if they could be sure that their life is the highest priority, right?
That's already not the case.
Yeah, that's what I was about to say.
People buy Teslas all the time, and they certainly don't make sure that you stay alive.
Well, it's
It's a very long debate. Some of it is actually up to politicians to decide how things should be handled, okay? And legals, there will be a bunch of test cases. So I'll give you a couple of examples from healthcare where things have gone south. So a long while back, there was like a radiotherapy device that was created. They gave a fatal dose to somebody and somebody passed away, and they actually sued the company. So some precedents of things like that will actually make people think about things. So what that would mean is, like, if you actually bought a car and if the car killed somebody, and if you are going to be sued for manslaughter, as in you, the occupant of the thing, then you start thinking about it much more carefully rather than thinking about what my value of life is, right? If I go to jail for until the end of my life, shit, man, I will really consider it, right? Yeah, that's a different question. I'm not a politician yet. It's an open question. It's an open question, and open questions don't come with easy answers. I mean, we as humans have to really decide which way we need to go, and lots of points in life. I mean, and evolution as such, and this is one of those things that we need to really recognize. You know, should we have machines as equals? Should we have other humans as equals? What should be the guidance to machines given in terms of questions like this? And if you can come up with an answer that's effective over a large set of times, I think that will solve a lot of those problems. Because we'll be forced to do it. That's what one of the person in the audience said. It's like Tesla already has crossed the path. So it's just a matter of time. You know, when we had cars introduced on the roads, we had the same question. We actually had like people running in front of it with I can't remember what it was, a flag or something like that, saying a car is coming behind, right? We have come to a point where cars can't drive on the road. So I hope something will evolve. You had a question? You want to shout?
So my understanding is that you are thinking about how to evaluate
Yeah.
things if your brain was used by branches to somebody else.
Yes. Not just to, you know, the concept is if you have a, you know, there are multiple things that you can think of. You can think of your brain talking to something else. So, yes.
But my question is, could you maybe, because you didn't go into the interesting detail,
Yeah.
by which method would you evaluate or assert that indeed it is being used?
Okay, so the first thing that you need to actually recognize is, you know, how do you capture all the so-called ethics into a machine-readable form? That's what we were trying to do, the very minimum, right? Then there's the question of valuation, meaning you should actually have some quorum mechanism or validation mechanism where you know for sure that, you know, at least a whole bunch of entities get the same results. So if you go to a court, you know exactly this decision was made using this ethics applied in this manner rather than randomly. That's the best we can do right now. So you can actually have like a verified system. So the trusted computing base would allow you to have a verified system. So the verified system will allow to have, you can actually attest to a set of properties to a third party, so revealing really what it was done. So that's what DAA really helps you. And then once it's done, if you have anything that's formally verifiable, that should give you the same results.
So then the question is, how do you tune or configure it initially? Can you shed some light into how you do that?
So how do you tune or, okay. Okay, that's an open problem. I haven't really fixed it yet. Oh, yes, go for it. Adapting, yes. So I fully agree with you on that problem. So part of the way we are looking at it was in a slightly what I would describe as a stupid way. That's my classic way of looking at problems. So sorry. So I was thinking of it as a graph. okay? And I looked at the graph and I looked at the points of the tree in the graph, which is a high probability of traversing. And you are able to apply a whole bunch of logic at that point in time to validate that. Will this actually go at this decision point or not? And if it is, then we have an idea. Where state space is really, really large and we have no way of going forwards and backwards, all these mechanisms totally fail. Put your hand up and tell you the truth. I mean, we can only try with very basic stuff. So an attempt. Somebody needs to start somewhere. Guys, thank you all.
Thank you.